Good morning everyone. I am Preeti Kiran, PGT Chemistry Kendriya Vidyalaya AGCR. Dear students, we have studied about the matter and its three physical states. Matter is everything around us. Matter can occupy space and has mass. Matter are of three types, that is solid, liquid and gas. Solid. Solid has a fixed shape. Solid has a fixed volume. Particles are arranged in a tight, regular pattern. Particles move very little. You can see that in the solid state, particles are not free to move. They are just oscillating about their mean position. Liquid. You can see in the liquid state, particles are freely moving. You can see that the movement increases when the liquid is hot. Gaseous state. How fast the particles are moving. They are free to move. Dear children, just because of this free movement in the gaseous and the liquid state, there is a property known as fluidity. Fluidity means liquid can flow and even the gases can flow. Solids, just because of the restricted movement, cannot flow. Let's compare the three states. The properties of the three phases of the matter. Solid, they have a fixed shape, but the liquid and the gases have indefinite shape. Volume, the solid have fixed volume, even the liquids have the fixed volume, but the gases have indefinite volume. Compressibility, we cannot compress solids. Even the liquids cannot be compressed, or if they can be compressed, then very slightly. But we can compress gases. That is, gases are compressible. Flow, solids cannot flow, but the liquids and gases can flow. Strength of the intermolecular attractions. In the solids, the intermolecular attractions are very strong. In liquid, it is moderate. But in the gaseous state, the intermolecular forces are very weak. Solids, they are further classified into crystalline and amorphous state. Now what is the difference between this crystalline and amorphous state? How these two states are generated? When the constituent particles are orderly arranged and the orderness is throughout, then that solid is a crystalline solid. In the case of the amorphous solid, the particles are not arranged in a regular fashion. If there is orderness, then it is in a very small portion, and these small portions are very scattered. So, depending upon the arrangement of the atoms, the solid can be a crystalline or a solid can be amorphous. Let's study the difference in the properties one by one. The crystalline solids have definite shape and geometrical form. The amorphous solids, they do not have a definite geometrical shape. The melting point of the crystalline solids is very sharp, but amorphous solids, they do not have the sharp melting point. For a range of the temperature, they get softened. The crystalline solids are rigid and incompressible, whereas amorphous solids can be compressed. Crystalline solids gives a clean cleavage. They show a cleavage property. When we cut them, the new surfaces which are generated, they have plane surface. This is not the case with the amorphous solid. When we cut an amorphous solid, we don't get a plane surface. Rather, we get an irregular surface. Crystalline solids are anisotropic and amorphous solids are isotropic. Quartz and glass, both are made up of silicon dioxide. The basic unit of quartz and glass is same. But quartz is a crystalline solid because SiO2 is arranged in a very ordered arrangement, and this orderedness is throughout. So it becomes a crystalline solid. But when this SiO2 unit is randomly arranged, there is no orderness, it becomes glass. Glass is an amorphous solid and quartz is a crystalline solid. Depending upon the nature of the bonding, further crystalline solids are classified. Let's see that. Bonding in the solids, specifically these solids are now the crystalline solids. There are 4 types of solids: molecular, covalent network, ionic and metallic. They are all depending upon the nature of the bonding. Molecular solids. The constituent particles are molecules. For example, noble gases, iodine, etc. In the molecular solids, 3 types of intermolecular attractions are found. They are dispersion forces, dipole attractions and hydrogen bonds. All these 3 types of interactions are very weak, and when the intermolecular forces are weak, the solids are soft and their melting point is low. I am discussing all the 3 types of forces in the molecular solids by taking suitable example. The dipole interactions. When there is a bond between the 2 dissimilar atoms and the electronegativity of one atom is higher than the other atom, the shared pair of electron shifts towards more electronegative element and it creates charge. We denote this charge by delta. Delta means partial. In the case of the water, you can see oxygen is more electronegative and hydrogen is less electronegative. So the shared pair of electron shifts towards oxygen. Oxygen has partial negative charge and hydrogen has partial positive charge, and this creates dipole. And due to this creation of the plus and minus charge, dipole-dipole interactions are developed. And since this dipole-dipole interaction is between the oppositely charged ends, so it is stronger. Bonding in the atomic solids like noble gases. We know that the octet of the noble gases is complete and they are in the most stable state. So they are monoatomic. In these monoatomic gases, the dispersion forces or the London forces are there. These forces are very weak. Now let me tell you how these forces are generated. You can see the helium molecule. What happens is the electrons are revolving around the nucleus. For a fraction of a second, what happens in one of the helium atom, accidentally the electrons, they come on the one side and that side acquires a negative charge and the other end acquires the positive charge. This positive charge attracts the electron of the other helium atom and shifts the electron towards it. So a negative and the positive charge develops in the neighboring helium atom, and this way, just for a fraction of a second, the plus and minus charge is created and this holds the molecules or the atoms together. Since this force is very weak, therefore the noble gases are in the gaseous state and their melting point is very low and they are very soft. The same you can see in the case of the iodine molecule. The melting point of iodine is also very less. This is just because of the weak van der Waals forces in between the molecules. Hydrogen bonding. Hydrogen bonding is comparatively a stronger bond. It is developed when the hydrogen atom of one molecule attracts electronegative element like oxygen, fluorine or nitrogen of the other molecule. We see this bonding in the case of water when the water is in the solid state, that is ice. You can see this crystal of ice, how the water molecules are regularly arranged. So we can say that ice is the crystalline form of water. Another crystalline solid, that is ionic solids. Ionic solids are those solids in which the constituent particles are ions, that is cations and anions, and there is a strong intermolecular force, that is the Coulombic forces of attraction or the electrostatic forces of attraction. Since these forces are very strong, Therefore, the ionic solids are very hard and their melting point is also very high. The ionic solids are conductors when they are in the molten or in the aqueous state. But when the ionic solids are in the solid states, they are insulators. Let's see some examples of the ionic solid. Cesium chloride, sodium chloride, zinc blende, fluoride structures, that is calcium fluoride, are ionic solids. Another category of the crystalline solids are the metallic solids. In the metallic solids, there are the positive ions surrounded by the sea of electrons. These electrons are freely moving, and just because of this free movement of the electrons, the metals are good conductors of electricity. And since the bond is very strong, they have very high melting point. Covalent solids. Covalent solids, the constituent particles are the atoms and they are bonded by very strong bonds, that is the covalent bonds. The covalent bonds are directional and they are very strong. When the simpler unit or the smaller unit repeats itself, we get the three-dimensional giant network of the molecules. We know that the diamond is the hardest substance, even the silicon carbide. And since the covalent bond is very strong, so the covalent solids have very high melting point. They are one of the hardest substances. And since there is no free electron or there is no free ion, so they are insulators. But there is one exception, and that is graphite. In the case of graphite, there are free electrons in the graphite. It is a good conductor of electricity, and due to its layered structure, graphite is soft and is used as a lubricant. It is an exception of a covalent solid which is a conductor. Otherwise, the covalent solids are insulators. Dear children, just now I have told you about the crystalline solids and their classification. How there are different types of crystalline solids depending upon the intermolecular forces. Just keep in mind, if the intermolecular forces are strong, the solids are hard and they have high melting point. But if these forces are weak, then the solid is soft with the low melting point. And the conductivity is only due to the presence of the free electrons or the free ions. If a solid do not have the free electron or the free ions, it will not conduct electricity and it will be an insulator. Hope everything is clear to you.